We now come to the applications of dot and cross product. So the applications of dot and cross product include first that how we are multiplying as a dot product or how we are multiplying as a cross product. So I have just to remember you that dot product is AB like this, and by multiplications what we have is AB cos theta. Now how we operate this actually should be learned from the dot product of unit vectors. Now say for example I am doing a dot product of I dot I. So you see the magnitude of I is 1, the magnitude of this I is also 1, and the angle between these two vectors, the cos theta is basically the angle between the two vectors theta. So the angle between the two vectors, as you can see, is 0 because I and I are both lying on x axis. So this is not just 0, but I would like to say it is cos 0. So you see, if it is cos 0, then what I can have the value as 1. So similarly, we can go on to write that j dot j, this is also 1. K dot k, that is also 1. And I hope you understand by now that if I multiply A and J, I mean I and J, then you can have an angle of 90 degree between them. So it is 1 into 1 into cos 90, which results to 0. So when we multiply two particular vectors, we have to take care that we only multiply I, J, K, and which is equal to 1. And all the other products actually cut out because they are all equal to 0. So now we'll take a practical example, an actual example, and check that how we apply this. Say for example, I have to multiply a vector of 2I minus 3J plus 2K with another vector I plus K plus J. So when I have a dot product, when I put it as A dot B, what I do is multiply I and I. So I, 2I and I is 1. I K, so K is 2. And J is 1 into 3, that is minus 3. So you see it is 4 minus 3, which is equal to 1. So that is how actually we are doing. Now we have to remember that when we multiply this, we have to consider the sign as well. So say for example, this particular vector now becomes minus j. So in that case, what will be our A dot B? You see, I'll be doing it. It is 1 into 2, so it is 2 again. It is minus 1 and minus 3, so that is plus 3 now. And 2 into 1 is plus 2. So that makes it 7. So this is all you have to remember for a dot, that whenever you are doing the dot product, you have to consider the J, K part only, and then you have to do the multiplication with sign, because that is very important. So for this change of sign, we have to remember that minus and minus makes plus, plus and minus makes minus, and so on. So now let us try to get on to the cross product. Now for a cross product, the situation is something different. What we ideally do is we make three vectors I, then J, then K, and then again I, and we rotate, we go on rotating in this direction and consider the sign. So you see, if I do I cross J, the direction I get is K. If I multiply J cross K, then I get the direction as I. And if I multiply K cross I get the direction of J. So if someone is multiplying in the reverse order, say he is multiplying I cross K, then he is bound to get minus J. So that is how the multiplication of cross products is done. Now in order to avoid this situation, what we do is apply the determinants. So now what we are going to do is we are going to apply the determinant form in order to comply with these rules. So let us check out how we can do that. We have a vector A, which is I plus 2j plus k, and B, is 2i minus j plus 2k. So when I multiply a cross product, I put it as A cross B and I write I, J, K like this. And then what I do, I put the coefficients of I, J, K accordingly. Say A, in I you have a coefficient of 1, so you write it 1 here. With J you have a coefficient of 2, so you write it 2 here. With K we have a coefficient of 1 again, so I write 1 here. And then for the B vector, we have for I 2, we have for J minus 1, and what we have for K 2. So now when you are multiplying this vector sequence, you take I, and what you do is hide I. So what you do is you hide I. You hide I and take the other two multiplication this order. 2 into 2 minus of minus 1 into 1. So 2 into 2 makes 4. And minus of minus 1 makes it plus 1. So it is 4 plus 1. Now you put the j as minus. Now this minus is very important because if you put it plus, then your multiplication sequence has to be reversed. So that might create a problem. So we take it at minus j and again we hide j. And then you multiply again cross this to this. So it is 2 and minus this to this. So it is minus 2. And then you take k again plus. Only j should be reversed and k should remain same. So when you are multiplying this k, you put this part of k hide, and when you hide k, you multiply this into this, so it is minus 1, and then this into this, which it is minus 4. So this happens to be 5i, and this 2 is struck off, so no j now, so it is minus 5k. So that is what is your answer, minus 5i minus 5k. So this is what we apply the cross product. So mind you, the cross product is actually done with help of determinants, and that is what we have shown you right now. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.